If the numbers appeared on the two throws of a fair six-faced die, fair dice means chance of getting each face is same, and the numbers are alpha and beta. Then we have to find the probability that this quadratic expression x square plus alpha x plus beta, this is greater than 0, right? This one is positive for all real values of x. Now we know that a quadratic expression is always positive if coefficient of x square is positive and the discriminant is negative. That means if I have this quadratic expression ax square plus bx plus c, and if this is greater than 0 for all x, so for that the condition will be that coefficient of x square must be positive and the discriminant must be negative. Coefficient of x square positive means we'll get upward parabola, and d negative means it is not touching or intersecting the x-axis. So in that case it will be always positive. So here basically when we are throwing two fair dice, so obviously the number of elements in sample space, this will be for first die we have 6 options, right? And for second die again we have another 6 options. So the number of elements in sample space, this will be 6 square, or the number of different quadratic expressions that you can create here for different values of alpha and beta. For alpha we have 6 value, for beta another 6 value. So number of different quadratic expression, this will be 6 square. Now we have to find that how many quadratic expressions are there which will be always positive, right? This should be greater than 0 for all real values of x. Now here you can see that coefficient of x square is 1. So the first condition is satisfied. Now we need to satisfy the second condition, that discriminant should be negative. Discriminant will be alpha square minus 4 beta. So this should be less than 0, right? Alpha square minus 4 beta, that should be less than 0. So from here you can say that beta must be greater than alpha square by 4, right? This is the condition that we have to satisfy. Beta must be more than alpha square by 4. So now let us take different values of alpha and then see what are the different values of beta that will satisfy that condition, right? So on one side we'll write values of alpha, and on other side we'll write the corresponding values of beta, satisfying the condition that beta is more than alpha square by 4. Also remember that alpha and beta, this will be any one of these first six natural numbers, right? Because when we are throwing a dice, we can get only these numbers. So let us start with alpha equals to 1. On one side we have alpha, another side beta. And for these type of problem, we have to create the table and then see the favorable cases. So if I take alpha as 1, beta should be more than 1 by 4. So you can take any value of beta starting from 1 up to 6. So these are the 6 different cases. Similarly, if I take alpha as 2, and we have to satisfy that beta is more than alpha square by 4. So now if I take alpha as 2, then beta should be greater than 1, right? So the numbers which you can take is, you can take either 2, 3, 4, 5 or 6. We cannot take beta as 1 because beta should be greater than 1, right? Beta should be greater than alpha square by 4. If alpha is 2, alpha square by 4 will be 1. Next possibility is if alpha is 3, right? If I take alpha as 3, then beta will, should be greater than 9 by 4. 9 by 4 will be 2 point something. We need bigger than 2 point something. So you can take any one of these 4 values, either 3 or 4 or 5 or 6. If I take alpha as 4, beta should be greater than 4. So either you can take 5 or you can take 6. Finally, if I take 5 or 6, then you can see that if I take alpha as 5, beta should be greater than 6 point something, right? 5 square 25 by 4, so that will be 6 point something. So in this case, you will not get any value of beta. And same thing you can say when you take alpha as 6. Right here, if I take alpha as 6, then also you will not get any value of beta. So you'll get only these cases. Now, how many favorable cases are there? So we have 6 plus 5, that is 11, plus another 6, so that will be 17. Right, that means if E is the event, that quadratic expression is always positive. So total we are getting 17 favorable cases. Also number of quadratic expression that you can create is 36. Number of elements in sample space. So therefore the probability of this event that this quantity expression will be positive for all x, this will be 17 by 36. So the correct answer for this problem will be first option. Right, so this was a problem where first you should know this condition that a quadratic is always positive if A positive and D negative. And then you can see that here uh, A is always positive because A is 1. And for D negative, this is the condition that we are getting, that beta should be greater than alpha square by 4. Now, for different values of alpha, you can take 1, 2, 3 up to 6. But for 5 and 6, we are not getting any value of beta. So only these 4 cases. And therefore, favorable case is 17, total 36. And the probability will be 17 by 36. Hence, the correct answer for this problem is first option.